It's not uncommon today to see a single stock crown molding profile used to transition from level to rake around an outside corner. This is accomplished by simply tipping or rolling the eave crown out of position so that it meets the rake piece like a normal outside corner. In classical examples, the eave molding always remains in its designed position, upright, so that its fillets remain plumb. This requires the use of a slightly larger custom profile on the rake. This piece gets a mitered plumb cut, and the cove portion is trimmed off with a level cut, leaving just the sema or S-curve portion. With the rake piece mating against the eave molding, a piece of the eave crown's bottom cove profile is added across the front to create a traditional split fillet detail. Not only is this historic approach more elegant, it can also solve other problems. By keeping the eave moldings in their correct position, it makes seamless transitions with other flanking crown elements easy. While this type of detail has always required more time and expense to produce, carpenters today have the advantage of 3D modeling software like SketchUp to cut down on design time. The first step in creating a rake profile in SketchUp begins by creating an accurate molding profile to use as a given. In the previous video we went through that process, and now we're going to use that profile to create our rake molding. I'm going to start by just drawing a simple box that I can use as a form to wrap my moldings around. I'll go ahead and make this a component so that the rest of my drawing doesn't get stuck together. And now we're ready to retrieve the molding that we created in the last video. After I created it, I went ahead and saved it as a component in a library on my computer so I can retrieve it quickly here. I'll go ahead and bring it out and put it into position. And this molding is going to run level across this side here, and then it'll be cut with a simple outside corner miter. To create that miter in SketchUp, there's a few different ways to do it. This is just one technique that I think works pretty well. I'm going to open that component for editing, and I'm going to draw in a path for follow me all the way to this corner, and then I'm going to go ahead and wrap it around the front. Once I've got that path drawn, I'm going to go ahead and select it, and then use the follow me tool to left click on that face, and that'll create an outside corner. To cut this piece of molding, I'm going to need to draw in the miter line. Here's one at the top we need to draw in, and there's also one at the bottom here. What that does is create a face inside that component. If I turn X-ray mode on, you'll see I've got a face in there now. Turn that back off, and now that I have that face in there, I can select just this piece across the front with a right to left selection box using the select tool. That'll select it, and if I hit the delete key, the piece across the front disappears. Now that I've got this miter cut, before I close the component for editing, I'm going to double click on this face. That'll select the face and all of its edges, and I'm going to copy it. This will store it in the clipboard on the computer. Now that I'm done, I'll close the component for editing, and if I go to edit, paste in place, I've now pasted that copy that we made right in the exact same position, but now it's outside of the component. The next step is to determine the slope or rake angle that we want this molding to travel in. We're going to use the protractor tool for that. I'm going to go ahead and hover on the front face here. You'll notice that the protractor is green in color. I'll left click on this bottom corner here and pull straight out in the red direction. That'll set our 0-degree reference point. And from here I can swing up and create a guideline at any angle. If I have a specific rise-run ratio that I want to use, say something like a 6/12 pitch, I can type in 6:12 and hit enter, and now that guideline is set at 6/12. If I have a specific number of degrees I want to create a guide at, I'll just type in that number, so 30, and hit enter, and now I've got a 30-degree angle. I'm going to use that guide to trace over with the line tool somewhere about there, And at this point I don't need the guide any longer, so I can just erase that. I'm going to use the follow me tool again. This line that we just drew is going to be our path. So I'll select that, and since we have that face pasted in here, I can just use the follow me tool and left click on it. That produces the molding that we need. It needs a little bit of cleanup. I'm going to triple click to select everything, and then I'll right click and we'll go to smooth soften edges. I can close this box, and it looks like this these faces are reversed. That's blue in color. I'm going to go ahead and right click and hit reverse faces. So now the outside of the molding is white instead of the blue color that represents the back face. If I use the push-pull tool on the end of this molding and pull it through the intersection, you'll see that that joint lines up nicely. In order to cut this molding, I've got that copy of the mitered profile still in the clipboard, so I can paste that in place again. I'll use a keyboard shortcut this time to access it. And once I paste it in place, I can then use the same technique of using a right to left selection box to select this portion and then hit the delete key. And you can see that now that joint is complete. If you swing up here, you'll see the actual profile of the molding. This has a square cut on it, so this is the molding profile that we're interested in. And one thing you might notice is that this bottom fillet is beveled, and it has to be. If we swing around the bottom here, you'll see that as that level fillet on the eave transitions, in order for those faces to line up, it has to be beveled. But in a classical eave return or in a pediment, there's a split fillet detail, and these portions of the molding never intersect. So we can just shave that portion off. I can do that pretty quickly with the line tool. Draw in here and then use push-pull to push the waist all the way down to the bottom. So now we've got a accurate profile that we can use to use as a template. I'm going to go ahead and double click again on this face. That'll select the face and the edges, and I'm going to create a component out of this as well. So the next thing we want to do is reset the component axis. If we look at the way the axis lines are set up right now, they're set up just like the axis lines in the drawing. And if we want to print this full scale, we'll need to make sure that we've got this profile aligned with one of the standard views. If we don't change the orientation of the component axes now, when we bring it back into SketchUp later, the profile will be oriented in the same position that it is now. Since we're going to want to make a full-scale print of this, we'll need to make sure we can align it with one of the standard views. While we could just rotate this profile once it's in the drawing, you can save some time by just creating the component in the orientation you want. While in a top view, you'll quickly notice that the red axis runs from left to right, and the green axis runs from top to bottom. But if you look a little closer, you can see that the axis lines are only solid in one direction, and they're dashed in the other. The red goes to the right, and the green goes up. This is how we want the axis lines oriented in our component. To set the axes for this profile, I'm going to left click at the bottom corner here to set the origin, and I'm going to pull straight out to the right to set the red axis, and then align this green axis straight up the back side of the molding. Once I left click, I'll be able to name the component. We'll call it Rake Profile, and create. Now that the component has been created, I can access it through the component browser. It's stored in our in-model library. All I need to do is left click on it and bring it into the drawing. If we go to a top view, you'll see we're all set up to make a full-scale print for this profile. And this is probably all the work you'll need to do for most examples. but some broken pediments have a plumb cut return on that rake piece, which requires a third profile, and we can do that with this same technique as well. To do that, I'm going to take advantage of this form box that we created earlier. I'm going to double click to open it for editing, and I'm going to double click to select just this face on the right side, and I'm going to rotate a copy out. So enter the rotate tool and then hit Control once to enter copy mode. I'm in the blue axis of rotation right now. I want to pin it right to that corner. I'll grab the back corner and then rotate a copy out. We're going to rotate this to 135 degrees, and that'll create the mitered plumb cut that we need on this piece of rake trim. While I've got it selected, I'm going to go ahead and copy it to add it to the clipboard, and now that it's in the clipboard I can simply click undo instead of erasing all those new edges and faces I created. I'll close this component for editing. I'll go ahead and make our piece of rake trim a component as well. I don't need to worry about giving it a name. I'm just going to go ahead and hit create. Now that the component is made, I'll open it for editing, and we'll do paste in place again to bring that new face in that we'll use as a cutting plane to cut through this piece of rake trim. I'm going to go ahead and triple click to select everything that's connected. If I right click and go to intersect faces with selection, the line that makes up that new miter is now in place, and I can start cleaning up. I'm going to go ahead and turn off the other geometry so it's not visible. It'll make things a little bit easier, and I'll go ahead and just erase out the edges and face that create that cutting plane, and then the same technique can be used here by making a right to left selection box to delete the waste. So now we've got the profile that we need to create our rake return. I'm going to go ahead and open that again because I need to double click to select the face and copy that. We'll close it for editing and then do another paste in place. I'll draw out the path for follow me, which will be just a level run to the back. We'll select that line, use follow me, and our third profile is created. I can pull it through the intersection again, do our paste in place again to cut the molding, trim off the side, and the molding is complete. A little bit of cleanup, but all we really need is this profile on the back. I'm going to go ahead and double click on this, and we'll create a component. We're going to set our component axis the same way we did earlier. I'm going to pin to the bottom, off to the right, and up for the green. We'll call this return profile, and create. So we can go back to our component browser, and now we have our rake profile and our return profile. And if we bring this piece in, you'll see it's oriented in the correct position too. With the profiles now developed and in place, they can easily be printed full scale on paper and used to create templates for use in the shop. They can also be exported full scale in a PDF file if you need to email them. If you're a pro user, it's easy to send them the layout so that they can be included in your plan documents too. Replacing this historic detail definitely takes more time and effort, but I personally think it's time well spent.